In task 4, I asked you to calculate the velocity with which Bruno in this video lands in the paddling pool. So we want to model this situation from the point he leaves the slide and find the velocity when he lands. And the information I've given you is that he travels a horizontal distance of 35.2 metres and he loses 6.4 metres on vertical. So to start with, we want to draw a diagram of exactly what is happening here. So if we take this as our origin here and he's landing in the paddling pool there, what we know is that there is a vertical height loss of 6.4 metres and a horizontal distance travelled of 35.2. And what we want to calculate, we want to calculate the speed with which he enters the paddling pool, so let's call that V, but actually we want the velocity, so we also want the angle at which he enters here. So what we know is that we can first start to think about which vectors we know here. So if we take our displacement vector, when he lands in the paddling pool, he has travelled horizontally 35.2 metres, and vertically he has lost 6.4 metres of height, so that's negative 6.4. We definitely do also know A, because we know the only force acting is gravity, so we know that is 0, and then negative G. Notice here we are taking upwards as positive, so we've got negative G, we've also got negative 6.4. The other thing we don't know, but the other thing we can put as a vector is the final velocity. So we can split this into components here, and we know that this here is V cos theta, and this here, well, this distance is V sine theta, but notice this component is in the negative direction, so this is minus V sine theta. So we can write down V as being V cos theta and minus V sine theta. Well, the other thing we do know is T, because you can time T from that video. I'm actually going to do the solution in terms of T, and then you can just substitute in your different values of T to see what answer you get, because obviously the values you get for the final velocity can depend on T. So T we do know, and T is probably about 2 seconds, but if you've timed something different, you can see how the answer starts to vary. So think about how we're going to proceed from here. These are the 4 things we've got. So the relevant Suvat equation is R equals Vt minus a half A t squared. And let's just substitute in the vectors we found into this equation. So we have 35.2 minus 6.4 equals V cos theta, V sine theta, minus 0 minus G. Oh, sorry, there's a T missing there. There's T minus 0 minus G T squared. And now let's just take the 2 components of this. So we take the horizontal component, we get 32.5 equals Vt cos theta. So 35.2 equals Vt cos theta. And let's make V cos theta the subject of that. So V cos theta equals 35.2 divided by T. And I'm going to call that equation 1. And now if we take the horizontal component, we get minus 6.4. I'm missing a minus there, because remember that our velocity here is negative. Minus 6.4 equals minus V sine theta t minus gt squared. So actually we get minus 6.4 equals minus Vt sine theta plus, because it was minus minus, plus g over 2 t squared. And similarly, I'm going to make V sine theta the subject of that. So adding Vt sine theta to both sides, adding 6.4 to both sides, and then dividing by t, we get V sine theta equals 6.4 plus g over 2 t squared, all divided by t, or if we multiply top and bottom by t, we get, sorry, no, not multiplying top and bottom by t, just cancelling a factor of t, we get 6.4 over t plus gt over 2. And I call that there equation 2. Okay. And what we wanted to find is we wanted to find theta, but we also wanted to find v. So the first thing we're going to do here is I'm going to divide equation 2, which is this equation here, by equation 1, which is this equation here. So on the left-hand side, we get v sine theta divided by v cos theta. And notice the v's cancel and sine theta divided by cos theta is tan theta. But that is equal to equation 2 divided by equation 1. So 6.4 over t plus gt over 2, all divided by 35.2 over t. And to make that a bit nicer, we can multiply top and bottom by t. So actually, what do we end up getting there? We end up getting tan theta equals 6.4 plus gt squared over 2, all divided by 35.2. Okay, so then theta, well, theta is just going to be the tan inverse of that. So theta is going to be tan inverse of all of that. And you can take your measured values of t and put those in here. And notice we don't really need to worry about adding 180 or anything like that, or getting a negative angle, because the way we set this up, theta was the acute angle here. So just your principal value of tan inverse is going to give you the angle at which Bruno enters the paddling pool. Okay, well, we still need to find the speed. We've got the angle, but we now need to find the speed at which he enters the paddling pool. So now what we're going to do is we're going to take equation 1 and square it. We take equation 2 and square it and add it together. So if we do 1 squared, add 2 squared, we get v squared cos squared theta plus v squared sine squared theta. But what was equation 1? Equation 1 was v cos theta equals 35.2 over t. So this must be equal to 35.2 over t all squared. And then equation 2 told us that v sine theta was this thing here. So we just need to square that as well. So we have add 6.4 over t plus gt over 2 all squared. But then if we look at this here, we can take a factor of v squared, and then cos squared plus sine squared we know is equal to 1. So this is just v squared. So we get v squared equals this. But actually we want v, and we know we can take the positive square root because it is a speed. So we get v is equal to this here. And then again, you can take your value of t and put it in. And I've calculated this for different values of t to show you what type of results you should get here. So if t is 2, you get theta is about 36.5 degrees, and we get a velocity of 21.9 meters per second. And you can see different calculated values of theta and v for different values of t there.